breakdown of today's release, our menu, very busy menu. So we'll, as we always do, begin with performance, something for nothing. So the software architecture has changed, so we like to see what we're going to get in terms of time saving for this. Then we're going to go to look at production stuff, turning and wire EDM. And then in the milling area, lots of things to see and do inside there, looking at the roughing cycle, looking at the new Raceline Cycle, which I'll talk about more when we get there. And then finally, going to look at the Toolstore. Got two brand new cutters to do with advanced 5-axis cycle, and of course finishing on, guess what, the advanced 5-axis cycle. So lots to do and to see in today's presentation. Two interesting items here for wire EDM. First of all, and this is actually does apply also to the 2-axis and 4-axis cycles, but you really should be using the smart cycle most of the time. We've got new tagging commands in there. So when we go for a manual strategy, users have been asking for more controls. So we're giving you 7 brand new different types of strategies, and this is all to do with when we break the workpiece away from the stock. So yeah, as we can see there on the screen. In terms of a manual strategy, and when we manually eject the part, we've got new tagging, and it's a triangular tag. So where we get a much thicker part or more stickier material, which is hard to break the workpiece away, it's better to have a triangular attachment as opposed to a parallel attachment. Just makes it easiest to break away. And this is what we mean by parallel. This is what we would have always traditionally seen, but now we get the opportunity to go for a triangle tag, and let's say it just makes that tag weaker and makes it easier to break away. So something for nothing, as I like to call it, on our yearly get together for the new release is performance boost. So our developers have been busy looking at certain ways of getting more performance from the system. And in this case, the usual suspect, the roughing cycle. I think we always do tend to pick on the roughing cycle. We're now getting a couple more minutes in certain cases, time saving for when we do rest roughing and select rest roughing as well. So something you don't need to actually do, it just does it in the architecture of the software. And so if you've got background processing on, what we were doing, we didn't really need to calculate in the stock. It's based on the toolpath anyway, so we've just tweaked the algorithm and we've got a better time saving. And as I always like to do, seeing is believing. So if we just jump over to the product, here we have 2023, and I guess some of you have seen me use this little macro before, where we do a timer. Just as we zoom into the part, you can see that we've got all these roughing cycles in there, rest roughing cycles. If I start my benchmark, it will clear our cache, so all the temporary data has disappeared and we regenerate everything. It's an internal timer, so there's no fiddling around, and the feedback on the bottom left will report how long that's taken. If I do exactly the same here in 2024, start the benchmark, again, you'll see on the bottom left, it's clearing the caches and it's doing a regeneration. You can see the background processes as well, because cycles 6 and 7 are now going that yellow-green, so it's making that recalculation for us. And if I just bob back to 2023, we just wait for it to catch up, we should see the result of that time saving. So as you can see here, we've got 42 seconds to reproduce those cycles. We bob back over here, we can now see in 2024, 28 seconds. So that's, and it's only really in comparison to the parts that production engineers like your good selves are creating, quite a big time saving for us, and that's just software architecture. So that's a nice big performance boost from 2024. Let's get back to presentation, keep me on track. So now we have some turning enhancements, and the turning enhancements again are a little bit to do with time and efficiency. So for those of us in the turning world, we'll know that we're turning on radius compensation. and we always get a small little movement as we turn on the radius comp, and this has always been built in within the software itself. It's quite obviously sensible to have this pre-movement so as the CNC software can apply that movement correctly. It's been a little bit excessive because the radius, these button tools that we tend to use on very, very large oil and gas parts would exaggerate the situation. So this is the sort of thing you'd see on a part in previous versions. You'll see that that long move, and that's now been eradicated. We don't really need to make that long move. We still get the feed move, the lead move, etc. It's just that that's been taken away, and I'll show you this more practically as we get into a demonstration. Also, the waveform turning cycle, and hope all of us are now using waveform turning, a great cycle for bringing down cycle time and giving us good tool longevity because there's less wear on them tools. We only used to have a constant offset. So again, you know, from people asking for enhancement requests, we've now got what we should need really is a separate Z and X, and this is just again keeping up with the Joneses. We're consistent with the other cycles where we do enjoy separate Z and X offsets. And why would we want this? Well, we want it because we want it, because we want to be able to control the tool path more stringently, and obviously to be able to leave more on the sidewall and less on a diameter, or vice versa. We're also seeing inside the finished groove cycle there's a reverse cut order. So again, you'd recognize that word from finished turning cycles, where we just rather than go from right to left, I'd prefer to go left to right. Dozens and dozens of reasons why we want to do that. So now we see that in finished grooving, and this really does play into the hands of the automation people. So those of you who are working with Strategy Manager, no doubt you can't manually switch it when you're in strategy, so I want a checkbox to do that for me. Now we'll see that working perfectly well in 2024. Okay, so let's put the theory into practice, diving back to the product, and I'll just pull up my first part, and this is our waveform turning. I'll just clear the previous part. Of course, if you've got any questions today, by all means, pop them into the chat if you wish to do so. Although I've said that now, maybe I might miss them as I'm talking away, but by all means, you can email me. I'll get back to you at the end of the session. So this is our waveform turning. I'll just turn off the background. So this is what we would have formerly had in 2023, only constant offset. But what I want to do is discriminate and say, well, I want so much in Z and I want so much in X. So I'll just put a big old number inside there and let it regenerate. And because I've got update stock on, you'll see that we've got this extra piece in the X offset, in the diametrical offset. Obviously on the sidewalls we've got less. Of course, on this particular cycle, just take note that I've got my angles on to give me relief on the tool, but clearly I've got a nice big old offset in the X. And of course, swapping that round, no problem at all. I want nothing on the X and a little tickle on Z. And again, that works perfectly well, as you can see here. Cool. Next item to talk about was that finished grooving cycle. So not particularly interesting because it's just reversing checkbox, but it does become really important when we work inside Strategy Manager. So if I can give you a Strategy Manager demonstration, or demonstrate this with the Strategy Manager, you'll see what I mean. If I make up a scenario that if I'm working in aluminium, so I'll go to the Toolstore, turn on technology, yeah, working on aluminium. What I want it to be is for it to be reversed, so the checkbox is activated. So if I just now play through, apply the strategy is now created my commands. Now we see the extra commands, and what we want to see now is the checkbox is now turned on. Checkbox turned on when we're working in aluminium, but if I work in something different, so let's just swap that technology. let's go say case hardened steel. I don't want it on. So we swap that over. I'll apply my strategy. It will run through the strategy. Now we have another checkbox or another piece of machining, and this time we see that the checkbox is off. So nice little demonstration of how strategies can work for us, and obviously now that's given us more power in the finished grooving cycle, which is what we all want from our software. The other item that I spoke about was the radius compensation. I'll bring up another part, but this is the part which was done in 2023, and you'll see that extra movement that we see here. That's not really required, that extra movement, because we'd have that built into the post and or obviously into the cycle. And this cycle time here for 4 minutes 45. So if I just do a regenerate and you watch carefully on the toolpath, you'll see that extra move taken away, or the stretch move taken away, and it brings our toolpath quite largely down. Now in this case, obviously that's quite a big time saving that we're going through. That's obviously more to do with what we see in terms of the post processor and the feeds and speeds. So maybe wouldn't be as much as that on other parts, but for sure, and lots of customers, and I tend to do talk about the oil and gas industry, where we see these big Webster Bennett vertical turning lathes, where we do tend to employ button tools quite a lot. This would certainly be the fix that we'd like to see. So here we have on a VTL, typical big old machine, several turning cycles, as you can see. Our cycle time, our overall cycle time at the minute, 2 hours and 46. And if I just do a refresh and a regenerate, and just do another verification now, so we've gone from the 2023 toolpath to the 2024 toolpath. What we're seeing now is this sort of cycle time saving. Okay, so that's our turning enhancements. Just going to take a little break there just to see whether we've got any questions coming in. Just reading through, seem to be, you're all definitely with me, I can see, but okay, so no questions at the moment. So we're all good. Yeah, that's fine. That's fine. Oh, question therefore about wire EDM. Yeah, so the wire EDM, the tagging also works in two-axis wire EDM cycle as well as the smart cycle. I know the slide said smart cycle, but yeah, you would find that process is still good in the in two-axis. Okay, so let's just go back to our PowerPoint, and then we go to milling. So I've called them milling enhancements, but of course we do MTM machines, we do mill turn machines, so of course, you know, the cycles are always relevant inside those areas as well. So first one that we'll talk about is SWARF clearance, and this is something that the turners for sure will know, because we have SWARF clearance inside Waveform roughing and inside the rough turn cycle as well, and we've introduced that into the roughing cycle in milling. What does it do? It divides up the tool path. So if I want to inspect the tool, if I'm fearful that, you know, the tool, the carbide is now expired, it will retire to a certain position and allow us to, as I say, inspect the inserts, change them around, or indeed in certain cases, certainly for the turners, they'd be clearing out the bird's nest, the swarf that tends to appear around the chuck. But now we have this facility inside roughing cycle. What it will do is it will obviously punch in a program M00 into the CNC tape as well. And there's also a little covert enhancement I'd like to talk about here, is that we now do show the program stop inside Machine Simulator, and indeed with the milling enhancement, if you just do a little bit of doctoring on the post processor, you can ask it to differentiate between, is this a program stop, a normal natural program stop, or is it a program stop where I'm in this roughing cycle and I'm asking us to look at the state of the inserts. So you take a quick picture of that screen, that would be the editing that you'd want to do inside the post processor. But of course, I'll show you this in a practical demonstration in a couple of minutes. Now on to the Raceline finishing cycle. This is a brand new cycle for 2024. And some of you might be saying, now I've not seen that. Well, you won't see it unless you've got preview turned on in your license manager, and you won't have preview on if you don't have a preview license. So this particular Raceline finishing cycle didn't quite make the perfect QA that we do on every single piece of software that we send into the release. We just want to slightly hold it back a little bit, but we thought it was worth just put your toe in the water and try it. So that's why we put it on preview. So if you want to use this cycle, and I'll explain obviously in a minute what it does, you will need the preview license. So contact my colleagues on support desk, or contact me, or contact your sales representatives, CSRs, Kim of the team, and they will just simply give you an extra piece on your licensing, and this will be able to turn on preview. With preview turned on, you'll then see Raceline finishing. At last I can talk about what does it do. So it's the racing line. It takes like a chicane, a motor driver taking the least distance between two places. So as it drives that path, it's finding the best position for the tool path, and therefore we do it in one pass if we can. And obviously better cycle time saving. So when we are finishing stuff, we've obviously got lots of different commands that we could use in terms of finishing. Those 3 cycles could be some of them, but this, I would argue, might be quicker and faster and a little bit more economical, and you can be the judge of it. So yeah, so this is the Raceline finishing cycle, and again, when you see the cycle, it will have all the usual suspects in there. So where we have a smaller tool and a broader cut, it can go into waveform for us as well, but you'll see what I mean when we get to the cycle itself. We've got a new checkbox in the chamfer cycles. So again, we're crying out for this. You see obviously use check fixtures in lots of other milling cycles. Why not in chamfer? So this is now being placed into the cycle. Obviously it will strip away the tool path where it sees collision. And there's also something else going on here, because we've made enhancement with the double angle cutters. So we've extended support and actually tightened up some of the algorithms that were behind the double angle cutters. So now it does support lower edge chamfering cutting where it wouldn't be possible before. And indeed, in certain cases, upper edge sometimes cause some challenges as well. So you'll find now that it's completely free of any issues, and you can chamfer away to your heart's content, basically, but as well as enjoy the avoid fixture functionality. And again, seeing is believing when we get to the demonstration. In the profiling cycle, another new checkbox, trim air cuts. So what does this do? Well, hopefully as that picture is showing us, where we have unnecessary cuts, don't do a cut. Obviously, this is a slice machining waterline cycle where it's duty bound to do a cut, but if you look where you're cutting, there's nothing to cut, so take the cut away. And this again will decrease cycle time because it doesn't need to take a pass. And this is a quick practical demonstration that, you know, this is what we would have had in previous versions, and now it will lift the tool away where it sees gaps in the sidewalls. So of course that's got to take away cycle time. So again, another winner in terms of efficiency. For the profiling and the roughing cycles, we now have another new checkbox to distribute the cuts equally. So basically, what we would have seen if this was a 60mm drop and the 9mm depth of cut, you'd get 6 passes, and that's 54mm gone. But of course now you've got 6mm to tickle away, which isn't great for the carbide. So what it'll do now, it will equalize it, and so now I'll have my cuts, but each cut will be 8.6 or 8.5 or whatever, but it'll give us an equal cut now. This is obviously better for carbide as well, and in certain cases can actually save a little bit of cycle time as well, so it's optimizing the process. Inside profiling cycle, when we go for cusp control, we don't always get toolpath when we're on a perfectly flat or near flat shape. Now it's possible because you can turn on continuous cusp mode. And I'm thinking more here people with standard licenses. So with a standard license, you wouldn't get finish shallow area, but now you can finish that shallow area because of this continuous cusp mode. And all will be revealed when I show you the practical part. It obviously applies across the board to wireframe and solids as well. So in the roughing cycle, waveform machining, we've got another control, and basically what will happen is that where you specify if the chip is getting thinner and you determine that size, we can reduce the feed rate down. So this has generally been dictated to us, so it's been 1.5 times it's been set inside the software. Now by you determining thin chip width, you can then control the toolpath itself. It will bring down the feed rate on the toolpath where it detects the chip is going a lot more thinner, and that's where basically you could force the sidewall over or chip the tool itself. Again, for the wireframe people, we've not been able to do overlapping when we're on 3D profile, which can be a bit of a pain sometimes because you can have a little bit of a nib of material on a sidewall. So 3D profiling just wasn't there. Well, what we'll find out now in 2024, indeed, we do have the overlap functionality, and we've actually changed the dialogue a little bit. So we just badged them up a little bit better, so it's more efficient to see where that functionality is. So that's for the wireframe people as well. Okay, so time to stop waffling and let's go into the practical stuff. So this is a little bit of a, not so much a trip down memory lane, but it will be a little bit normal to the turners. So I'm going to talk about SWARF control. SWARF control, rough turn cycle, and the waveform cycles. I've had this. I explain it as, you know, being able to clear away the SWARF and do a program stop. So we've got this in rough turn and also in the waveform. If I throw this into the simulator, this kind of shows us the side of the enhancement with regard to simulator, because now you can see that, I roll down a little bit, we're seeing them program stops actually appearing now in the CL data inside machine simulator, and they obviously come out inside the CNC tape as well. Didn't used to do that. So now I've got program stop on here, and I just push forward, it will pause and stop as you would see it on the machine. So that's a nice little enhancement. May have come in at 2023 or in a service pack. I might have missed it, I can't remember, but yeah, for sure it's worth talking about. So that's what we mean when we talk about SWARF control. Now the enhancement in terms of 2024 is inside the roughing cycle. So the mill roughing cycle, bring our part on, we'll now see that we've got inside our roughing cycle the same functionality. So again, you know, the turners will be more and more used to seeing that. And I say the idea is that after X number of minutes, or after so many passes, what I want to do is to be able to yeah, to make a decision, look at the inspect the inserts, and then begin to change them or not. So what we've got here is a tool path which is well 26, 27 minutes, we'll say. If I say, well, break after 7 minutes, let's come back here, 7 minutes, lift us up to 150 in the Z, and you don't have to fill in X and Y because that'll just cost more time, the tool crossing somewhere else. Just want to go up in the Z, and then do me a stop program. So with our 7 minutes here, we should see a pause. I'll just break that down for us quite nicely. So that should give us around three different pauses within our tool path. Let it do a regenerate, and then we'll pass it into, what we'll do here is we'll go into rapid result, because obviously it's a longer running tool path, so it'll just be easier to use the good old rapid result. And in rapid result, I'll just set down the, obviously I don't see the CL data in rapid result, but I can see the stops. So yeah, I'll turn off stop a collision. We have no collisions, hopefully. Yeah, so I should have 3 stops here. So press and start, 1, 2, 3, and then we go to the end of the program. So yeah, so that's something that users should be very, very aware of. And of course, when you code, you should see them stops appearing as well. Let's run over our code. And if I just ask it to go and look for moo, there we go. So you can see that we've got these program stops taking place, which are specific to the SWARF cycle because of my little editing inside the post processor. So I should have 3 of them. 1, 2, 3. Yeah. So SWARF control inside the roughing cycle. The other one, it was the racetrack. So remember, this is the preview license. If you need that preview license, contact the guys there on support desk, or indeed your sales contacts. Yeah, so we'll see it on the menu. This is one we've done earlier, so it will follow perfectly the profile. If I just turn on SWARF, Swathe rather, not SWARF, you can see it's just followed the line perfectly for me. And all I've just done is pick the front face, and it's done the calculation where to place the cutter. And we'll just roll into cut, roll back out again. Cut. So on, around. Okay, great. And as we look at the cycle, again, we shouldn't be shy of it at all. Lots and lots of usual suspects in there that we'd see and notice and realize. So we should be zero training required for this. So if I say, oh, well, pretend that the stock is thicker, I'll say 3 mil. If you watch the tool path, it will just jump a little bit. So now I've gone a little bit further across the racing line. I do an undo. Or not deleting anything, undo. I meant to do that. Undo, yeah, you see back on step again. So that was with a 3 millimeter stock thickness, just shoves it over a little bit for us. If you went a little bit too much, which is quite cute because it's obviously detecting the relationship between the diameter of the cutter and the area that it's cutting, it will wrap my knuckles and say, yeah, you should have a bigger tool for that. And that's going to happen lots and lots of times. Or what happens if I don't have a bigger tool for that? So nice little function is that you can go, yeah, I want 5 millimeter, but then do my waveforming, so it's picking up the good old waveform algorithm as well. So you're seeing it's doing them extra cuts in the realm where it believes a smaller tool couldn't cross over. So yeah, it's a really interesting cycle. We'd love your feedback on it. So if you think that it's something that you could work with and could use in your daily life, then by all means tap us up and we'll sort out the preview license for you. For sure, there's lots and lots of practical reasons why I think you'll want it. The one that I would definitely say would be in terms of cycle time saving. Just as a little bit of an experiment, here is a typical kind of industry part. Here's our roughing cycle, making a perfectly good job of it. This particular cycle is 6 minutes and 17 seconds. And every single cycle, by the way, I haven't cheated. Everything's got the same feed rates on it. So six minutes, we'll say. If we did our face milling cycle, obviously that's more uniform, isn't it? Typical face milling cycle, up and off, same feed and speeds, same step over. And again, you can see that we've got a higher cycle time there. But if we use Raceline, the racing line, you see that we're down to 4 minutes. So there's quite a big cycle, time saving there. And it's just tracking around that shape, giving us the best cut that we can get. So you get a completely good clean up. So in preview at the minute, love you to say, love your feedback by all means. You know, you might find things that it could do with improving, or Lord forbid, you might find a little bug in it. So please do report back to us, and we'll fix that and have it absolutely perfect for 2025. Okay. Let's look at our next enhancement, which is to do with the double angle cutters. And here what I'm going to do is I'm going to go back in time and just show you a before and after. So I've just jumped into 2023. Load up. There we go. So yeah, so in 2023, again, typical industry part. Got my chamfering cycle, got my double angle cutter. All looks great. Take it through into the machine simulator. Play away. Doesn't quite cut the mustard, doesn't quite cut the part. So your usual reaction would have been, all right then, well let's up these values, play around with the values. So I'll say, well, I'm 1 millimeter depth and 20% contact, and it cries foul. And this is where the algorithms need to be tightened. So flat wrist can't do it. So what would you have done? So like good old production engineers, you would have just, as you can see me doing now, I'm just putting a normal everyday chamfering cycle, a chamfering tool in there, not a double headed tool, double angle tool, moving them numbers up again. Will it work with me on them numbers? And yeah, not a problem. So it's great, yeah, we get round the problem, we box clever, we use just a normal everyday chamfering cycle, and that will chamfer that to its heart's content. But hey, what about the double angle tool? And obviously in the double angled cutter, we want to be able to go under these edges as well. So that's the current frustration that we would have seen in 2023. So here's the same part in 2024, exactly the same part. If I lift up them numbers, if you remember, they argued with me before. I'll lift up the numbers now. We see no argument. Quite happy to take them numbers on board. So the adverse collision checking is not working against us. Now it champers away quite happily. Hooray, that's great. So, and obviously now we can go on to do the undercuts as well. So great, we've got that cycle working. So I'll use a separate cycle to machine the next edge. So I've made a copy of the cycle, drag and drop, turned off the previous CAD. I'm just going to go for this loop, and then just leave everything be, just let it get on with it. Of course, quite happy to cut, but cuts too much. It's gone right through the clamp. And again, this would have been a frustration back in 2023. We would have had to do maybe 2 cycles and do different start and end points, or use a containment. No longer necessary. A lot of effort now is now being saved. Just say use the check fixture, And as that updates, you'll now see it's removed the cut in and around the naughty area. And how about undercutting? Because obviously I want to finish this in one. I don't want the extra burden of having to unclamp it, reverse it, reclamp it, and then machine it again. So I want to use the underside of that double barrel cutter. So what I'm doing now is I'm making a third copy, and I'll just ask it to do a chamfer on the underside of this chap here. So all live, and happy to do that live because we can see that it's not only undercutting for us with that double barrel cutter, which wouldn't have been possible in 2023, we're also jumping around then clamps. So perfect way of looking at that enhancement in 2024. Okay, you can see a question come in, proving that you're awake. I've got preview cycle. Oh, someone's asking that they've got a preview cycle, preview license, but don't see the racetrack. I've got a preview cycle. Might be because in your license manager, you've not turned on preview. So just have a wee think about that. It should normally just appear. There should be no reason. You should now see racetrack just appearing in the drop down, unless you've done some editing in the theme. So what I tend to do if I think I'm missing something, I would just type it up here to query something. So you just type in, there you go, Raceline finishing. So you use the quick search. But yeah, for sure, if you got the preview license, then you should definitely have that. Right, where were we? Oh yeah, so we're now going to be talking about the profiling cycle. So the profiling cycle here, as we can see, is beginning to do all them extra cuts. So what we want to do now is so we just want to make sure someone's got their, could someone please mute their microphone? Someone's just turned on a microphone somewhere in the background, so that just needs to be oh great, you can see that's been done now, lovely. Profiling cycle is now got several new enhancements, which again will allow us to have a nice old cycle time saving on it. What we see here is our toolpath quite legitimately doing waterline slice machining at 4 minutes and 17. Now you might notice that the last cut is just a little dribble of a cut, which really wouldn't be great for the carbide. So we're at 4 minutes and 17. First enhancement to show you is to distribute the cuts equally. So remember, distribute cuts equally appears inside profiling and also inside roughing. So let that take place. And now we see that we've got equal cuts and a little bit of a cycle time saving, 10 seconds. Okay, not great, but better to be in my pocket than in anybody else's pocket. 10 seconds cycle time saving. So that's just simply shows us the distribute cuts evenly. But the big time saving here is all the wasted cuts it's taken around this area here where there's just fresh air. I only wanted to cut where it really legitimately needs to cut. This part's being turned around later on and being cut from the other side. So looking at another time saving here, and we see actually there's two new check boxes, fine trim on edges, but this is the real catalyst here, trim air cuts on undercuts. And if I just activate that, you can see now it's only placing the tool where it should go, where the slice should legitimately go. And of course the cycle time saving is quite a lot, over a minute and a bit. Don't know what that is in percentage, can't work out in my head, but certainly, yeah, again, a big old cycle time saving coming in from EDGECAM 2024. And of course, you know, you'd have a bigger cycle time saving if you were doing your links were set a little bit lower as well. You wouldn't need to travel up in the air as much. But yeah, for sure, one checkbox, big old cycle time saving there for us. Moving further forward, just want to quickly talk about, because that was obviously the profiling cycle, and I want to talk about the profiling cycle again. And now really concentrating on the wireframe, people, because sometimes get accused of, oh, it's all solids and it's all features. So this is one for the wireframe, and if you remember the standard license as well. So here we have wireframe. We're machining the wireframe coming down the side wall using continuous, which is perfectly legitimate. And what you'll see, I just move the dialog box out of the way, is that there's no cuts in the flat area. You'll see that there, no cut. Another flat area, no cut. And even in a solid model, no cut. Now with a solid model, what you might be able to do, and again, it kind of like depends on license as well, you might have been able to say finish shallow area, but some of us don't have that. And of course you wouldn't have it on wireframe. So as I say, that's why I keep mentioning wireframe. So now what you'll have, you've got this new checkbox called continuous cusp mode. So keep using my cusp wherever we are on the part. And now you'll see it's cut all the way on the external part. I'll do that one more time for the internal pocket part. Continuous cusp mode will be coming on, and you can determine the angle as well. Here I'll just assume it's at 0. So you'll see again it's traveled right across that flat zone. So really nice enhancement, that, because it means that we don't have to do any extra cycles to cover them flat areas. You know, you might have had to do a flatland finishing cycle or a profile cut or something. Now no longer necessary. Right, let's move back to the PowerPoint. Not doing too badly for time. And good, yeah, we've got a bit of time here now to talk about the two big hitters that I believe are in 2024, the Toolstore. So within the Toolstore, and concentrating on advanced 5-axis or 5-axis in general, we have two new cutters, a taper shaped barrel and a lens cutter. So these are really popular tools that customers have been asking for, and legitimately now we give that in 2024. We have had obviously barrel cutter, but now we want taper barrel. Why would we want it? Well, I've stolen these two screenshots from our colleagues at Seco and at Quick Grind. This speaks volumes to me. This is why people are using taper shape and barrel cutters, because you can get a better surface finish in a lot smaller cycle time, because you don't have to do such a big, small depth of cut or cusp. So this is why it's a high frequency request. 2024 delivers. So this is what 2020 delivered. So the drop shape barrel, or the 2 radius barrel cutter. And of course, we've had a template to be able to explain the shapes and sizes of that particular drop shape barrel cutter. But here, new at 2024, the taper barrel, taper shape cutter. So it's normally a 3 radius tool. Again, used in lots of applications, not just aerospace and medical. We see it all over the shape at the moment, all over this place at the moment. And we have also a lens cutter. Lens cutter, one person described it as a lollipop cutter with the sides taken away. Yeah, so we've got a big old belly in the middle of that cutter. It's really good at high feed cutting. So 2 templates completely available now inside 2024. Now, how am I going to explain this? Well, first of all, let's have a look at the Toolstore itself. We'll bring up a part. So I'll show you the Toolstore, which is pretty simple, because obviously it's just the template now, which is great. This is going to be using a lens cutter. So let's have a quick peek at the Toolstore. Here's the new arrivals on that bottom right there. So we see our lens and our taper before we did have barrel. Now in this application, what I've got is, let's just turn off that toolpath, is a belly on this part, 4,533. So it's not flat. Let's use the old detect render. Yeah, so this is definitely not flat, so I can't use base milling or something. So what we would have very legitimately done in previous versions is use parallel lace, keeping the lacing cycle quite close. Parallel lace is very good on near flat, shallow parts, and it will just cross over the shape for us and do a pretty good job. But now what you can do, and this is very interesting news, is that you can use the lens cutter in a 3-axis pose. So it's not kind of exclusive to 5-axis. Yes, most of the time it will be 5-axis, but here's a really good, really nice application for the lens cutter. So rather than spending 8 minutes, we've got 8 minutes and 30 seconds using parallel lace and a ball nose cutter, what you could now do, and I'm on the 3-axis milling, and I've picked a lens cutter, and with lens you'll be able to do machining of this part. So here is my lens cutter, quick view of it, nice and simple, which is what I like. Upper diameter, convex tip radius, so these will be obviously matching whatever tool you've purchased. And with that cutter now enabled, you will be able to use the flow surface cycle, because some of you may know that the flow surface cycle is actually based on the 5-axis cycle anyway. So I'm flowing my cut from one face to another, and I'm using the same feed and speeds that I did for parallel lacing, but I've got a much broader cusp on here, like millimeter, which is crazy. But we can do that with the lens cutter. So you'll see that the actual steps between each pass is a lot broader compared to, if I just go back to parallel lace. So there's the parallel lace. And if I show you the surface finish, I'll use the rapid result in this case for flow surface cycle. So now you'll see it's slightly better surface finish. Now it's pretty hard to tell when we're software rendering inside GoToWebinar, but certainly the cusps are a lot shallower than what they were when we used the ball nose cutter. So we get a very big cycle time saving, so 5 minutes on the first flow surface cycle, 8 minutes on the ball nose cutter for parallel lace. So that's why we're making changes, and that's why we're seeing these new cutters being placed into the software. So there, take note that in the 3-axis world, you can use it, because if you've got an advanced license, you can be using your flow surface cycle. Now, this is, I suppose, really the major reason why we're using taper cutters, taper barrel cutters. So again, very legitimate and normal piece of machining. I've got a ball nose cutter using advanced 5-axis cycle, if I can say it, and we're coming down the side wall. If I just throw that into Machine Simulator, you'll see the cuts swing around. Now again, I've been very conservative, same feeds and speeds on both of these cycles, but because of the geometry of these tools, the broader the cut, the worse the surface finish. But I might just get away with that surface finish, probably not, but for sure I could now tighten the step overs in this cycle and give myself a better surface finish. So in this particular case, what we got 0.4, so I'd have to start bringing that down a little bit more. And what we got, 15 minutes. Now, same part, same tool, same setup, same everything. I've just got a different sequence using the taper barrel cutter, so the 3 radius cutter. Again, let's have a quick sneak peek of that inside Toolstore. So again, we're seeing the profile radius, the lower radius. So all these are matching the tool that you've taken from whomever you take tools from your supplier. One little trick I tend to do is, because these shapes are very complicated, I tend to download the tool from the vendor. In our case, we've been working with Quick Grind quite a lot, so I've downloaded their template, downloaded their console, and made a comparison to the EDGECAM console just to make sure that my interpretation of profile radius or run out radius is the same as theirs. So that's always a nice little tip or trick for you to make sure that you are applying the right value. But the cycle, as well as being the same feed and speeds, but what we can see is the steps a lot broader, which normally would signal problems. It would normally signal that you're getting a worse surface finish, but because you're using that taper barrel cut, and again, it's difficult to see with software rendering and over GoToMeeting, but yeah, so those surface finishes are certainly better. Could be better still, so, but yeah, for sure, look at this. I've got only 6 minutes of cycle time, whereas what do we have? Nearly 15 minutes before. So why would I want to use these tools? So that's a very easy way of explaining. Get these tools in 2024 and use them. Now that very nicely brings me on to talking about the 5-axis cycle. So the advanced 5-axis cycle has 2 new strategies in there. First one is the rotary axis machining. As it kind of you would expect, it's for 4-axis. It points the tool into the center. You can use it in lathes and obviously to milling machines, or you can state the axis of control. Multiple different types of strategies. Very, very easy to learn. As I say, it's pointing the tool into center, which is kind of what our rotary feature finder does, our rotary command. This one, we've got the added bonus of actually offsetting the tool as well, so you'll be able to get better chip control. And again, lots of other commands inside the cycle that allows us to do a better tool path compared to what we might have done previously. You know, you could have used an advanced cycle blend between 2 curves or something like that, but this is a dedicated cycle for 4-axis. The thing that really points out to me in testing this was it'll beat rotary feature every single time. Rotary feature, a lot of people would tend to give up on because it's just not made for the job sometimes. Yeah, it's great on simple stuff, but you could argue that it's not quite good on some of the shapes that I've got. So for sure, this might be a really, really good answer to it. Yeah, and it's a very, very simple cycle to use, so you'll notice it's been very, very cut down. Maybe seeing is believing, so let's quickly jump to the product. Let's get our example open. Just watching the clock. So this is rotary. Very, very simple part. Let's just have a look at the part. So the kind of issue that you would have had, I just go here. So we were to try and hit this part with rotary feature finder in a previous life. It really kind of doesn't matter how I set this up. And I want to think about this floor and this island. It would have just kicked back. It just would have said, no way, Jose. And we would have had to think about different things. Power unwrap tends to come to mind sometimes. So that would have been a certain challenge. We could have used our 5-axis cycle, but the 5-axis cycle sometimes, you know, what you're doing is you're trimming it down to suit 4-axis. So this is the new cycle. So the advanced 5-axis cycle, guys, there you'll know exactly what I'm going to be doing. There we go. There's our new jump down, our new strategy, rotary machining. We can obviously rough and finish with it. Part definition, we just simply pick the part, pick a boundary, pick the stock, and just let it do the rest. And as you can see here, without a lot of fuss or nonsense, just pick and go, not a lot to learn really. Let that throw it into the machine simulator nice and quickly. So yeah, that would have been a little bit of a challenge. Well, challenge, but they'll have to work a little bit harder, which we don't like, do we? And yeah, it just machines that quite happily. Where I see this an awful lot is worm screws, augers, this sort of thing. Probably pronounced that wrongly now. So this would definitely have been a blend between two faces or two curves in the cycle. So if I quickly show you, there we go, rotary machining set on. I'm going to be doing some roughing, and all I've just done is pick the part. You just go pick the part, talk about the axis of rotation. In this case, we're on the milling machine, so I'm going through the X. It is stock sensitive. This will just drive the tool very nicely down the center of the worm or the auger, and do the business for us again. So yeah, really would recommend this one. Real game changer, in my opinion. And what we've done here, thanks to my colleagues, friends over at Wims Engineering, we've actually done some practical machining. Well, thanks to John and the team who were daft enough to allow me on their machine one Friday morning. So we just done some test cuts just to make sure that everything was working well, which it did. It was a Haas machine that them guys got, and straight away, yeah, we just did a nice simple part with a pocket and island inside there. And it worked out perfectly well for us. So thanks to those guys down at Wims. And there's the actual part machining itself. So seeing is believing. It's always good to know that it is actually doing the business, not just in the theory world, but we're seeing it in practice as well. Right, so over to our final bit for 5-axis machining, and this is again another strategy inside the 5-axis cycle, multi-axis machining. So picking and unstrapping all the 5-axis, moving it around, and of course this will support normal cutters, but will play very nicely into the hands of barrel and lens cutters as well. In this particular instance, what we're seeing is that we've got two different strategies to enjoy as well when we're doing roughing. We've got offset roughing, which is a little bit like our concentric. We've got adaptive, which is very much like waveform, and obviously we've got finishing as well. And this again, you know, multiple industries this can be used in, but why would they want to use it? Because we get better tool pass, reduced cycle times, and obviously cost savings. Just out of my head, really, why would I want to use it? If I'm using 5-axis, it means that the tool can follow the floor. It means that we're going to be able to get more material out in a quicker way, because don't forget we can use adaptive machining here. And this is what we'd see if we were using the new multi-axis. If we're using good old waveform, nothing wrong with waveform, but of course it's a 3-axis cycle, so it will do slice machining for us. So therefore you'd get these big chunks when you're doing water lining. Of course we can fight that by using intermediate slices, but of course, you know, that would cost us more time. So as I say, different strategies, different cutting methods, all names that we're going to be familiar with, and a specialist cycle inside the adaptive cycle or inside the multi-axis cycle called undercutting. So again, you know, we wouldn't dare do this with waterline machining, where we've got an undercut, negative angle, call it what you will. The tool will be able to reach into those areas, and it's going to be done in one. There's no need for extra operations and extra tools. Obviously, if you're doing that with slice 3-axis machining, you're not going to be able to do that. You're not going to be able to get into the shadow, into the undercut area. So the cycle does give us lots of possibilities, lots of different ways of working. So with finishing, we can morph the tool path from the floor up to the ceiling down to the floor. It's giving us a better surface texture all the time. So getting very excited about it. Let's just see that. This is our last demonstration for today. Let's have a look at undercutting. and the cycle itself. And remember, we're working again with the three radius taper tools and the lens cutters. So this is the cycle. So we're not doing rotary, we're not doing deburring. That was, what was that, 2-3 versions ago. We're doing multi-axis. We're activating roughing and only roughing. We can either do adaptive or offsetting. In this case, what I've gone for here is undercutting. Again, the interface is trimmed down just to ask us what we need to be asked in terms of this cycle. So it's a specialist dedicated cycle, multi-axis machining. You can lift up your feeds and speeds. It is stock sensitive, as we can see here. So going down the chamber side wall. So how would we have done that with 3-axis? You know, we would have to possibly do a move index and then another move index to get to the undercuts, maybe use a lollipop cutter, but it wouldn't have been the best strategy. So now we've got this extra strategy for us to work with. And a lot of the aerospace parts, really difficult stuff for us to machine. This particular new strategy, multi-axis, opens up a lot of doors for us. Here we have a bit of a mock-up of a part that I've seen myself. So we get these crazy shapes in aerospace. If I just go and say, well, let's just do normal everyday waveform machining on this part, Waveform will do a perfectly great job. Obviously we're using high feed and speed, smaller step over, depths of cut, but we will have to go back in with intermediate slices. Rock and roll. We can't leave out that, so intermediate slices then go on. That's fine, but of course that costs us cycle time with the intermediate slicing. And of course it can't go everywhere because of course the tool's got to remain perpendicular to the axis. So if I turn on view comparison, you'll see there's a lot more blue area on the floor, which gives more work to the finishing strategies. Now if I do exactly the same in the multi-axis world, I'll just switch to the strategy, show you the cycle again. So we're multi-axis roughing, adaptive. Just pick the parts, and you pick all the body itself, and I've used a containment. And it asks us for the floor, so it's the whole of the floor. We think of maybe morph between curves, morph between surfaces, but the floor is obviously a much bigger shape, and therefore gives us a better shape of tool path, considering the whole of a contour. And again, let's just chuck that over into Machine Simulator so you can see this. Let that rock and roll. There we go. So again, an equal depth of cut to what I had inside waveforming. And I've used the cycle also enjoys the benefit of adaptive machining. So like waveform adaptive is the word that's used inside 5-axis. And it's also got intermediate slicing, so the sidewalls will be nibbled as well. But more importantly, what you can see is, and both cycles have been set to 0 offset, it's nearly got to the floor itself. And all I need to do now is machine the sidewall with the finishing cycles. So the adaptive command, really big winner for us.